a rectangle and adding radius corners and things like that, I'm not going to get into the specifics of that. So if you see me flying through it, that's basically what I'm doing. If you have a question about something, if I'm moving too fast, just stop me and let me know, and I'll backtrack and come back to it. Okay, so we're going to do a basic shower pan here. The creation of this geometry is really quite simple. The surface is quite simple. The difficulty, or not even really that difficult, but it's trying to understand a little bit how the machining it, to add the machinings, and what the options are when you're adding the machinings. So I'm going to start with a simple rectangle. Let's just say 48 by 24. I'm going to offset it 2 inches. Maybe put 2-inch radius corners. Now it's important when you're choosing the radius corner of the slope and of the surface, because basically this is what I'm creating is geometry that I'm going to be using to create my surface. So, but I have to keep in thought what the size of my tooling is. So in this case, our stubbing wheel is 100 millimeters, roughly 4 inches. A little bit less. So I'm going to do a 2-inch radius. That way, when we're cleaning up this surface, the stubbing wheel can get all the way into that corner. Okay, so the radius corners here will be my what we call the guide, and that's where the surface is going to follow this guide. Now, when we create a surface for the shower pan, we have 2 selections. We have to make a guide, and then we have to make a section. The section is kind of the profile that we want to follow along the guide. So I'm just going to do something here really quick. Let's just say a 1-inch by a 1-inch square. And I'm going to make this, let's say, a 1/2-inch radius. Now, I'm only going to use this radius as my section. So I'm just going to leave the radius there. When we create it, we're going to tell it what point along it. But remember, when you create this radius, if you're doing it as a radius, just like we worry about this radius, I'm sorry, if you need me to, I'll hit Control here, and you'll be able to see where my mouse is pointing if you're having any issues with that. So just like when I created this radius, I need to remember, like if I got a ball end tool, I need to factor in what this radius is going to be when I create the surface. If the radius is too small for my ball mill, then I won't be able to get into that surface and create the proper surface. Okay, so we come into the Build tab. When we come in here, this is where we build our surfaces. You'll see the geometry color will change automatically. So you can choose which geometry color you want to use. And let's just say green. Okay, so I'm going to come into shower pan, box shower. So remember, this is the guide. So I'm going to select all that. Okay, and then this is the section. One thing I forgot to do is I like to draw the center of my slope beforehand. So I'm just going to use the center of this shower pan as the center of my slope. So back into shower, select guide, okay, select section, okay. Now this message gets cut off, but it's point guide section. So this is the relationship of the guide and the section. So what point of the section do we want on the guide? So really, I want this endpoint. Now, if I look at it isometrically, you'll see that I've got that radius following that guide now. Okay. Okay, so that's why I drew this diagonal line, because that's the center of that line, or the midpoint of that line is going to be what I'm going to use for the center of my slope. Okay, now if you look, you see I have basin checked here. What the basin does is create your drain for you. Okay, I don't like to use the basin. The problem is that it draws it in as a surface instead of just taking a normal mill bit and telling it to drill a depth of whatever we want for a depth of our drain. So normally I uncheck basin. Okay, then we see the depth. So this is the depth here isn't from the top of the material, it's from after your section. So we had a 1/2 inch radius, and now let's say we go 0.2 depth. So a total depth from the top of the material would be 0.7 inches. Okay. Okay. So now we see our surface. If we do a front view, you'll see how it's sloped. Okay. Now, I'm going to change the color of this line because I'm also now going to create how I like to do my flange. So instead of doing the basin option when I create the shower pan, I like to make my own. So I'm going to put in, let's just say it's a 1 inch, and then I'm going to do another circle at the center. Let's say it's 3/4, so 1.5 inch drain. Okay. So I'm going to use this circle as the flange of my drain. And then the internal circle is what I'm going to mill out for the drain pipe for the 1.5 inch PVC down. Okay, so when I apply it, I'm going to apply 2 different depths. They're going to be 2 different kits that I'm going to apply. Okay, so before we go on and apply the machining, let's talk a little bit about the tooling. So I'm going to do the roughing with your standard stubbing wheel. See, it's almost a 4 inch tool, 3 3/4 inch, so roughly what, 90 or almost 100 millimeters. We see the feed rates here. I'm going to show you something. Normally we don't use a head feed defined in this if we're only using it to plane the material. So when we apply this, we're going to see the time estimation be a huge number until we start to play with some of these feed rates. Okay, and then I have just an electroplated ball end mill. Again, these feed rates are probably a little conservative, 20 inches a minute. We have 0.4 inch radius, 1.5 inch. So this is a bull nose, not a full true ball circle end. And then the kits are standard kits. I didn't do anything to them when I made them. So you have surface rough and surface finish. I'll explain the difference of those as we apply the tooling to them. Okay, so we see the stubbing surface. I just said surface rough new, and I dumped the stubbing wheel into there. Same thing with surface finish new, and then I dumped the ball end in. So we have all of the default values in the kits. You of course can change the values to whatever you're going to be using all the time. Okay, so I'm going to assume we're putting this, doing this out of 30 millimeter material, 1.181 stone. Okay. Okay, so the first thing we can do, we could talk about creating the drain hole. So I could put my normal milling tool on here. If I could find it. Okay. But this is where I'm saying the depth. I don't want the depth to be all the way through. Okay. This I'm going to do. I had 0.5 radius down 0.2, so I'm 0.7 depth of the sink. So I want to be roughly, let's say 0.95. Okay. So if we do a front view, we can change this to get the depth of our stubbing wheel or depth of our milling bit out. And I know it's kind of hard to see underneath that surface. If I turn wireframe on, you'll see it there. Okay. So we're just going to mill this out not at full depth. So we're going to leave a little bit material for the flange. And for the pipe, we'll go full depth. Okay. So we see just the recess and then the full all the way through. Okay. Now I'm applying it to the surface. So we have surface rough and we have surface finish. So there's two main differences between the surface rough and the surface finish. That's why we have two different types of kits. So the surface rough kits are going to look at all of the material that we've defined. Okay. So what you're going to see is, even though I'm only selecting these surfaces, when I apply the surface rough kit, stubbing surface, it's looking at basically my entire box and it wants to remove any material to get down to that surface. Okay. So if you look right now, it's going on the outside. It's doing kind of some crazy things. So I don't want it to be outside of my surface. I want to keep it inside of my surface. So I'm going to do a couple different things here. I'm going to come into the contour function. Contour function is basically going to tell the software, I want all of my machinings to stay inside of this geometry. So I click the contour button. I tell it I want to stay internal of this geometry. I'm going to select the geometry that I used for my guide originally. And I'm going to say define contour 1. Okay. I'm going to come in. I'm going to check here some of my settings. So my depth, okay, I don't want it to go full depth. Let's say 0.8. Let's say we want to step at maybe 100 thousandths of an inch at a pass. And we can hit apply. Okay. So what you're seeing is each one of these step downs is this 100 thou. Now, what we have is a distance run. So the tool diameter is 3.75 inches. So that's what it's using as the distance run, meaning it's burying the entire tool in to do that removal. That might be a little bit too much of a hard work for it. So maybe we'll cut it in half. We'll say roughly 2 inches. And I'm going to shut fast preview off so we can see all of it. Okay. So now we see way more cutting here. I can go ahead and we'll start a simulation. So we're doing 2-inch step overs and dropping down 100 thousandths per pass. So if we look at the time, so that's only going to be 36 hours. No, I'm kidding. Remember I said we don't have a head feed in here. So the head feed is how fast we're going to be plunging. So if we put something in like 20 inches a minute, like we would, we'll see. Now we're down to an hour. But maybe we want to say 75 inches a minute for our work. Now we're down to 44 minutes. So we could play with this. Of course, it depends a lot on the material. Okay. Now, you see, when we do this, remember that's a surface rough. So it's getting rid of all of the material to try to get down all the way to that surface that it can. Now when we select the surfaces and we do a surface finish with a ball end mill, okay, now it's a direct link from the tool to the surface itself. Okay, I'm going to shut fast preview off just so we can see more machinings here. Okay, so the standard default came in looking like this. I can kind of play with these. Are going to be like my entry exit points. So maybe I want to start over here. Something like that. Now, this path that's defaulted on here, like I said, that I just created a kit and threw it in there. So automatically it's going to be longitudinal direction. Now, what does that mean? It means basically it's X and Y interpolation. So if I start a simulation, you'll see here. So you see how it's only moving in X and Y around the part? Okay. I can switch this to transversal. And now the tool is moving up and down that slope. Or we could do both longitudinal and transversal. Okay. In this case, it's going to be a while to do that because it's going to do both. Now, we still have the distance run. So in this case, the distance run is going to be, let me change this back to just, let's say we're just going to do this transversal. So the distance run is going to be the step over that we have here. So the smaller the distance run, the better the surface is going to look like. And let me make a virtual mill of this so I can show you. Okay. Okay. I think Benji asked me, he didn't unmute himself to ask, but He was asking if there's a benefit to doing it transversal or longitudinal, and it's more of what the finish is going to be like coming off the machine. I prefer to do a transversal because that's kind of how we would normally do a shower pan. As far as having a slope to it. So it's kind of hard to tell. So basically, you would almost have drain paths down to the drain if we do it transversal versus longitudinal. The other thing you can do also, if you prefer to do some of it in one way and then have it the other way, that's what these are for. So this is longitudinal and this is transversal. So how much of that surface we want to do in that type of machining. So I could say I only want to do 50 to 100% of the machinings here. And then we don't do everything. That's probably a bad example, but let's do 50 to 100 longitudinal. Okay. So you see, we're only doing this section. Oh, our surface is messed up here, but this is telling it how much of it. So if we didn't want to do the whole surface in that machining way, we could change the way it's working here. Let's see. Somebody had a question and I didn't see it. Tavi, you had a question? No. Okay, so we could define the contour here. Keep that in. It's already on there because it's a finish pass anyway, but say okay. Switch to showing the power sim. I know graphically it doesn't look very good, but you get the idea. Okay, so that's about it. I'll go ahead and you can turn your mics off if you have questions, or turn your mics on to ask questions.
Ben,
Yep.
is the roughing tool following the slope, the taper, or just the finishing passes? Is the roughing passes also following the slope or just the finishing passes?
Just it's following the slope, but leaving it in as a step. So it's not in this case, it's not an interpolated movement with the Z. So if we look at these machinings, so these are always staying at the same Z height, but they're following the surface, but they're not. The head isn't moving in Z. There's not an XYZ interpolation, only an XY interpolation on the machining.
So only the finishing passes are active in Z.
Yeah. Yep.
Thank you.
Okay. And then let's see. How do you avoid the tool starts right on the top of the surface? Problematic when the stone isn't perfect. I'm going to assume you're talking about this. Oops, wrong one. Yeah. So we have to change it to direct, so it's not coming in on top of the stone. One thing I forgot to touch on, in the surfaces, I know we have normal runs or feed runs, but we have a first run feed rate for this tooling. So if we were doing small step overs as our distance run, let's say we were doing a 1/4 inch step over, we could tell at the first run, which would be the entire tool doing all the machining, we could tell that to run a little bit slower. Oh, sorry, wrong one. The first run at 10 inches a minute, and then every run after that is only taking a 1/4 inch of material at a time. So we could really pump that up to maybe like 50 inches a minute. I mean, of course, it depends on what you're trying to finish. If it's you need a good finish, your step overs would be very small. Okay, Benji asked if they have a 4-axis machine, is there a benefit or time saving by using a blade, or is that not worthwhile? On a shower pan, I don't know. I don't think it would save you very much time. The problem with a saw blade is, uh, depending on what your shower pan was going to look like, you couldn't get into this radius very well. You couldn't apply the machinings very well in that radius. So uh, you would have a lot of material left there for the ball mill to get into. Okay, no other questions? All right. Well, thanks everybody for their time. Everybody should have my email if you have any questions or want a copy of the video. Just shoot me an email and I'll send you a link to it. Otherwise, have a good afternoon or evening or whatever you're doing, and talk to you guys later. everybody I know.